Okay, our study of linear equations and linear inequalities is going to result now in looking at some application problems. Applications is a fancy word of saying word problems. All right, before we start tackling some word problems, first I want to tell you a little bit about George Polya's four-step process. Then we're going to solve formulas for some specific variables, and then we'll look at some word problems. I'll go through some particular examples to help you to see how to do those types that you are responsible for. All right, so first of all, George Polya, educator who taught at Stanford, he was educated in Europe. He wrote a book called How to Solve It, and he was the first really math educator to sit down and write down the consistent four-step process for solving problems in mathematics, or any problems really. Number one, he says, understand the problem. It's like, well, yeah, of course, you gotta understand it before you can do anything with it. And to achieve understanding, start out by reading it. You'd be amazed how many people don't do that. Then it doesn't hurt to reread it just to make sure you're getting that information in your head and really understanding the scenario given. And then as you're going back through it, if you need to go through it a third or fourth time, do so. But as you go back through it, make sure you see what are they giving you, what are they asking you, what is it you need to go find. Then once you understand the problem, then you can start devising a plan. Some problems you might start drawing a picture. Other problems you might start doing a chart. Some might need a table. You know, you got to start organizing, devise a plan to organize your information, get everything out there, get your unknowns or your variables labeled, start creating equations, you know, got to figure out what is it I got to do here. And then carry it out. Once you have everything set up, you know, start doing the work you need to do from according to your plan. If you set up some equations, solve them. You know, and then go through and work things out, and then make sure you fully answered your questions. Some people will solve the equation they got, and then they'll not go back and make sure they answered the question that was being asked. So, you know, make sure you've answered everything, and then finally check, check, check. Make sure your answers make sense. Make sure they plug in and work. You know, that kind of thing. So like if it's asking for the length of a side of a triangle and you get negative number, then you know, something's not right here. You know, I need to go back and fix that, or you know, look at it, make sure it makes sense. So that's the four-step process, and that's the basic procedure I will be following as I show some of these examples to you. Okay, but before I start actually doing word problems, I need to go over something called solving for a specified variable. Often when you're doing word problems, you will be working with formulas. And often those formulas you're working with, you might be solving for a variable in the formula. And so it helps to be able to rework the formula for your purposes. There we go. All right. Let's say, for example, you are working with the formula for perimeter of a triangle. The formula for perimeter of a triangle looks like this. Basically, it's saying find the perimeter of a triangle, you add up the three sides to see what the total length is. But let's say you know the perimeter and two sides, and you need to find the third side. Let's say that you need to solve for C. Well, it can help to have the formula rewritten. Instead of P equals, say C equals. That can be very helpful. So solve just like you would solve for an equation. Because the formula is an equation. It has an equal sign. P equals A plus B plus C. So if I was solving for C, I would look at this and say, well, I've got an A plus B being added over here. So I can think about doing the opposite from both sides. I can go ahead and subtract A from both sides. I can also subtract B from both sides. And that would just leave me with C on the right and P minus A minus B on the left. And now you have the equation rewritten. So if you know perimeter and two sides, you can use this equation to find the third side in a triangle. Let's see, how about if you have something a little more complicated? What if you have a little bit like this? What if you have y equals a times x minus h squared plus k, and you need to solve this for a. Okay, this is actually a formula you're going to be using a lot in this course. It's, later on you're going to be dealing with trying to work with parabolas. So you're going to see this formula as far as the equation of a parabola, and then trying to graph them and so forth. But for now, let's say you know your y, x, h, and k, and you're trying to solve for a. Let's say you don't know what the a is, and you have to find it. Well, you can rework this formula. You can solve for a. First of all, I'm looking at this, and I'm seeing this whole thing here is being multiplied. So I'm not going to touch it right now. But this plus k, I can work on that first. What I can do is subtract k from both sides. So I'll have y minus k equals a times x minus h squared. And then, I draw my k's, they end up kind of separated there. All right, and then I'm still trying to solve for a, and I notice that I have a times x minus h squared. So I can go ahead and divide both sides by x minus h squared. And next to the a, x minus h squared over x minus h squared will just reduce to 1. So I'm going to have just plain old a, and it's going to equal y minus k over x minus h squared. And now I've got the equation solved for a. So sometimes as you're working these problems, it might be helpful, to solve a formula for a different variable and then use that. Or if any of you, some of you have mentioned in the introductions that you're going to go into computer science. Computer programming, often when you're writing a program and you need to use a formula, you need to be able to do this so that you can put the formula in a specific way. Like this formula over here, if you can have it set up so that if somebody inputs P, A, and B, the computer knows how to do the math to solve for C. Or on this one, if somebody inputs H, K, X, and Y, you can program the equation in so that the computer can solve for A. So those of you going into computer science will especially find this useful. Okay, let's move on to actually doing some word problems. And to do that, I'm going to pull some problems from the current book. So even if you're not using the current book, it's okay, because I'm going to pull them up and show them to you. The same kinds of problems you're going to see no matter what book you're using right now. Yes, I'll keep my annotations and I'll post that later for you. But here I'm here in my math lab, and I pulled up the ebook, and I'm on this current section that has the word problems. And I'm going to go and pull up each word problem that we're going to do, and that way we can see it, and then I'm going to switch over and actually do the work. So we're going to start out in this book with this number 8 here, and its title has Perimeter of a Storage Shed. A carpenter must build a rectangular storage shed. She wants the length to be 3 feet greater than the width, and the perimeter must be 22 feet. Find the length and width of the shed. Okay, so she's a rectangular storage shed, so we know we're dealing with a rectangle. She wants the length to be 3 feet greater than the width. Okay, so the length is going to be longer than the width. It's going to be greater than the width. by 3 feet. So the width is the shorter part, the length is the longer part by 3 feet, and the total perimeter, the total distance around this rectangle must be 22 feet. And we're trying to find the length and width of this shed. Okay, I've read this enough times, I feel like I have a good idea about what's going on. So I think I can get down to starting to devise my plan and organize my information. I know I'm dealing with a rectangular shed. Excuse my really poor drawing skills, I'm sorry. And I'm going to go ahead and let's see, this is the width, it's the shorter part, that's W. And then this is the length, the longer part, and that's L. Well, if the width we can just leave as W, but they told us the length is going to be 3 feet greater than that. So we can take whatever the width is and add 3 to it, and that'll be our length. All right, then it also said the perimeter is 22 feet. So we're going to need to use that as well. Well, I know the perimeter of a rectangle can be found by doing twice the length plus twice the width. That's basically the same thing as adding up all the sides, but you got 2 lengths and 2 widths to add up. So the 2L plus 2W, according to the problem, has to equal 22, because that's the perimeter. But also according to the problem, we know that the length is 3 more than the width, so we can replace L with W plus 3. Because of this. And now we went from having this equation here that had 2 unknowns, L and W, to an equation with only 1 unknown, W. And we can solve that easily. Distribute the 2. Combine like terms. Subtract 6 from both sides. Divide by 4 on both sides. We get W equals 4. And then with L being the same as W plus 3, we just add 4 plus 3, and we get 7 for the L. So the width is 4 feet. The length is 7 feet. And if you go back and look at your numbers, the length is 3 feet more than the width. And if you have 4 plus 7 plus 4 plus 7, 4 plus 7 is 11, plus another 4 is 15, plus 7 is 22. The perimeter does indeed come out to 22 feet. So it works. You know, that's the simple as your check can be. Just go back and make sure the numbers work. Okay, next problem. Yes, I want to keep my annotations. Next problem, we're going to tackle number 14, so that'll be on the next page. Number 14 refers to number 13. It says repeat exercise 13 for a television screen having a perimeter of 126 inches. All right, so number 13, the aspect ratio of older television monitors is 4:3. One such television has a rectangular viewing screen with perimeter, they say use 126 inches. So we're doing the same problem, but different perimeter. What are the length and width of the screen? Since televisions are advertised by the diagonal measure of their screens, how would this monitor be advertised? Okay, so if the aspect ratio of older television monitors is 4:3, what that means is you can take whatever the length is here over whatever the width is there, and when you reduce the fraction, you have a ratio of 4:3. So the length is 4/3 of the width, and we can use that. And we're looking at the total perimeter being 126. We have to figure out what the length and width are. We also have to figure out the diagonal. Okay, so let's go do it. So full screen, here we go. Going back to my pen. Let me draw my little rectangular TV screen. I'm going to go ahead and let the width be W. And then the length is 4/3 the width because of the aspect ratio of 4:3. Problem tells us the perimeter is 126 inches. I've got 2L plus 2W equals 126. Well, I can replace the L with 4/3 W. Because of the aspect ratio. So I've got 8/3 W plus 2W equals 126. And then at this point, I don't like fractions, so I'm going to go ahead and multiply the entire equation through by 3. And that'll get rid of my fraction for me. Combine like terms, I get 14W equals 378. Then divide both sides by 14, and I get 27. And then L is 4/3 of that, so 4/3 of 27. It's going to give me 36. And now I've got both width and length. So width 27 inches, length 36 inches. I've not found the diagonal yet. Remember, go back and look and make sure you've answered the question. Well, the question asked for length and width, but it also asked for the diagonal. So I still have that piece to do. Okay, now diagonal, doesn't really matter which diagonal you look at, but you know, it's from corner to corner like this, corner to opposite corner on these. The diagonal in this one cuts across and we form a right triangle. We know the width is 27 inches. We know the length is 36 inches. And we're trying to find the diagonal, which I'll call x. Well, this is a right triangle, so I can use the Pythagorean theorem, which I learned earlier in the chapter. A squared plus b squared equals c squared. So I can say 27 squared plus 36 squared equals x squared. Well, 27 squared is 729. 36 squared is 1,296. You add those together, you get 2,025. And then you do positive square root of 2025, and you get 45. So the diagonal is 45 inches. And that's what they mean when they tell you the size of the television. If they say you have a 45-inch television, it's telling you you have a 45-inch diagonal on your TV. So there's that. All right. To avoid getting too long with one video, I think I'm going to pause here, cut off this video, and make another video for some more word problems. It's still the same section, but don't want to make the video too long, so that's what I'm going to do right now. So tune in for the next video to continue the word problems. Thank you.